Okay, now we use mesh analysis. Okay, so we just need to write KVL equation in loop 2. Okay, so how many resistance share with loop I1? How many? How many? What's the value of the resistance?
1
The
ampere.
value of the resistance 1 ampere. How many resistance share with loop I1?
2.
2 ohm, okay? 2. So that's why minus 2 I1, this is I1, okay? Loop I1 plus 6 plus 2 is 8, 8 plus 7 is 15. 15 I2, and how many resistance share with loop 3? How many? 3. How many resistance share with loop 3?
1.
1.
Give me the value of the resistance. The
7
value of
ohm.
the resistance.
7 ohm.
Sorry? 7.
7 ohm.
Yes.
Okay, minus 7 I3. Okay, I3 is equal to 0, but we know that I1 is equal to 1 amp and I3 is equal to 4 amp. So we substitute I1 and I3 in the equation. So minus 2, 1 plus 15 I2 minus 7 multiply with 4 equals 0, and we get I2 is equal to 2 amp. But the question asks you to find V1 and V2. Okay, so V1 is the voltage of 2 ohm. So we need to find the current flows through 2 ohm. Let's name it as I4. Okay, same goes for V2. V2 is the voltage drop across 7 ohm. So V of 7 ohm is equal to current flows through 7 ohm multiplied with 7. Let's name it as I5. So how to find I4? Okay, we apply KCL at this node, okay, or at the top node here. So here is I2 because I2 flows through 6 ohm and through this path, okay, and here is I1. I1 flows through this path. So we apply KCL. Sorry? We apply KCL at this node. So I2 plus I4 is equal to I2 plus I4 is equal to I1. We want to find I4. I4 is equal to I1 minus I2. I1 is equal to 1. I2 is 2. I4 is minus 1 amp. So V1 is equal to 2 multiplied with minus 1 equal to minus 2 volt. Okay, the answer is minus 2 volts. Same calculation for V2. Okay, we apply KCL at this node. We name this current is equal to I5. This is I3 or 4 amp. Here is I2. Okay, so I5 plus 4 is equal to I2. I5 is equal to I2 is equal to 2. 2 minus 4 equal to minus 2. So V2 is equal to 7. Multiply with minus 2 equal to minus 14. Can understand or not? If yes, say yes, start yes.
Yes, doctor, yes.
Any question?
Yes, doctor. Yes.
Any question? Okay, now this question is taken from textbook Sadiku. write voltage equation. This question should be in order analysis. Okay. Later I will drag this slide to nodal analysis subtopic. Okay. So write node voltage equations by inspection. This is the answer, meaning that this is the first equation, the second and the third equation. Okay. And the answer is, okay, the question only asks you to find equation only. Okay, no need to find the value of V1, V2 and V3. But from this equation, we can find V1, V2 and V3 by calculator. Okay, but if the question only asks you to write, so just write, do not solve. Okay, now let's do it together. This is V1, V2 and V3. We have 3 nodes only here. So at V1, this is current enter the node, this is current leaving the node. Okay, so 20 milli I put here, 20 milli is equal to V1 divided with 2K plus V1 minus V2 divided with 4K plus V1 minus V3 divided with 1K equal to 20 milli. Simplify the equation and we get this. This is the first equation. Now we go to the second equation, second node at V2. Okay, up to you. You can specify the arrow of current, but the equation must follow the arrow of current. You can make it enter the node, you can make, or you can make it leaving the node. Okay, at V2, so V1 minus V2 divided with 4K plus 5 milli enter the node equal to current leaving the node is V2 minus V3 divided with 4K plus V2 divided with 2K. And we simplify. Okay, now please do this together to find the final value of V1, V2 and V3. Now, do it now. This is the second equation. Okay. And then at V3, at V3, at V3, V2 minus V3 divided with 4K plus V1 minus V3 divided with 1K
Again, Doctor, what?
equal to 10 milli plus 5. Yes.
Madam,
Yes.
we need to follow like V2 and V1 apa tu kita buat macam dia punya current pergi ke kanan kan. We make the current go to the right. But if at V3 the node V3, if I change the current going to the left, it will be wrong, madam. Will it be wrong?
Meaning that
Kita kena follow sebelum ni punya lah.
meaning that ulang balik soalan. Repeat your question.
Madam, like at the node V1 and V2, what do you call, we estimate like the current will go to the right, madam kan?
Yes.
But if at V3 node, if I make it to the left, like outside the node, like going out from the node, so will it be wrong, madam? Since
You mean the current here?
sebab macam kan yang current 10 milliamp kan masuk V3 kan. Kalau saya buat macam dia pergi ke kiri, boleh, madam?
Which one? 10
Uh,
milli?
10 milli at the node V3.
Okay. Okay, now. Okay, 10 milli. Now 10 milli enter node V3, right? You're right. Huh?
Okay, 10 milli enter the V3. Then from V3, there is current going outside to the left to the 4 kilo ohm resistor. But since I made that V2 node current going to the right, also towards the 4 kilo ohm resistor, boleh ke, madam, macam tu?
Siapa ni cakap Himan
Saya English problem, madam.
Himan,
Ya,
you
saya.
speak Malay first. Then, okay, you speak Malay first.
Okay. Melayu. Okay, contohlah kalau dekat node V3, madam kan, kalau saya buat current tu, dia pergi kat belah kiri daripada node V3 tu. Current 10 milliamp.
10 milli, 10 milli.
Tapi kalau sebelum tu saya dah buat V2 punya node tu.
10 milli ni dia masuk V3.
Masuk V3. Tapi macam boleh ke saya buat dia pergi belah kiri tu, madam, masuk 4 kilo ohm punya resistor? tak boleh dia macam tu
Kejap. Dia akan masuk node V3. You nak macam mana? Cuba you lukis, you snap picture. You nak macam mana? Tak apa sebab 10 mili memang akan masuk V3. You nak dia masuk kat 4K.
Tak, kalau dia tak masuknya
Memang dia akan masuk point yang sama. Kat sini lah. Cuba you lukis.
Okay.
snap
Nanti
picture.
saya tangkap gambar.
And then you put here. Okay?
Okay.
Okay class, please proceed with this question. Equal to minus 5 milli, right? Okay, so this is the third equation. Now we solve this equation. Okay, if you solve this equation, what will be V1, V2 and V3? Let's try. Please try, all of you. Class, try key in this equation in your calculator. What is the answer for V1, V2 and V3? Okay, please find V1, V2 and V3. Okay, now let's solve this question. Okay, so let's assume that this answer is correct, given by Wali and Nora Afika. Okay, now let's compare with my equation or your equation. Okay. I think my answer is wrong. Class, please Correct me if I'm wrong. I think this one is wrong, but I write it first. Okay, seems like this is wrong. Class, please solve this question and please solve this question and compare your calculation with the answer. How to calculate?
Madam,
Yes.
madam, ada orang nak tanya.
Kan Can't hear your voice.
Ada orang nak tanya.
Hmm.
Nama dia ni. Divin Rajkumar.
Yeah. This one.
Madam, saya tak faham macam mana nak calculate.
Can't hear. I can't hear your voice. Louder, please.
Saya tak faham macam nak calculate pun. Dapat V1, V2,
Use nodal analysis.
V3. Analysis.
Class, get the answer or not? Anybody get the answer? Anybody get the answer? Please compare our answer. I think this one still wrong. So this is the challenge in nodal analysis. We must be very careful with our equation. Okay, I think still wrong. Okay, please someone check whether my Sonal Africa and Wali, did you key in this equation in your calculator and you get this answer?
Yes, doctor, yes.
Okay. So have you calculate this by yourself and get the same answer? Get the same answer, so that way. Please check my calculation. At V2. Check my calculation, please. Okey. Tolak dengan equal 20 mili. Minus V1 over 4K. Tambah dengan okay. And then at V3, V2 minus V3 over 4K plus 10 milli plus V1 minus V3 equal 5 milli. Minus V1 over 1K plus V2 over 4K. Okay. So, can someone check my calculation? Where's the wrong? Okay, so okay. 2.5 sampai 2.5. Okay, and okay, so I just check my equation with the metric. So the first equation is right, and then but everything in this equation is in milli. Okay, everything in this equation is in milli.
Madam,
Yes, 1 milli
Madam,
and then milli. Okay, the second equation is correct. Okay, and then the third equation minus.
Madam, I have
okay, and
different.
oh, this one. Okay, this one I think positive, right? Because positive here. This one also minus here. V2 minus V3. Okay, so minus here and then here is V2 minus V3. V3 V2 minus V3 over 4K plus V1 minus V3 over 1K plus 10 milli equal to 5. No, everything not include 5 milli. No, V3 include. No, V3, this is 5 milli. We have 4 branches here, 1, 2, 3 and 4. Enter, this one is enter 5, okay, and then equal 5 milli. Okay, but now I found that this equation is, this is minus 1, this is minus 1. Here is negative. Okay, so something wrong here. Everybody, can you understand this question or not? Okay, so this one is yes, this one V1 over 1K. V1 over 1K, this one must be positive. Positive.
Ma'am, I
This
have
one
a
is
different with your second equation. I have different value. I calculate when I calculate.
Who's speaking? Unclear. V1 over
Ma'am, 14.
1 over 1K and then okay, so this V1 over 1K, V1 over 1K plus V2 over 4K. Okay, so positive here. Okay. I think you will get the answer. So now I have to key in the equation again. Three unknowns. Okay, so please be careful because of mistake in negative and positive, your answer will be wrong. Okay. So now this is my first equation. Everybody please try. Everybody get the answer or not? Okay, this is the V1. V2 is please remain your answer in 3 decimal points. Okay. Okay. Since this equation, okay. So I think we can accept. Okay. How's your answer, Wiley? Who else? Wong Boon Heng. Did you get the answer exactly as this? 36.43 and so on. Exactly the same or not? Exactly the same? Exactly the same. So I think my equation is correct. So I think my equation is correct, same as this, okay? But maybe this actually I should get the same answer, exactly the same, okay? Because only 2 decimal points here, okay? Never mind, but please check again and make sure you get the answer is this. Tak boleh. Okay, this is the answer. Okay, so this is nodal equation, nodal analysis. Any question want to ask me? If we use mesh analysis, we will have 1 mesh, 2 mesh. Okay, only 2 mesh to solve because this mesh the current is 20 milli, this mesh the current is 5 milli, and this mesh the current is 10 milli. Okay, but this is yes, this is a super mesh. We did not cover super mesh in our syllabus, so you can solve by using mesh analysis, but we did not cover super mesh in our syllabus. This is super mesh because for 5 milliamp is super mesh because this is current source. It is located between 2 nodes. Okay. Any question want to ask regarding this question? Any question? Can I understand or not? Class? You can understand or not? Please say yes or no. Or type yes or no. This one. B3 Yeah. B3 minus 5/4 B3. Why 5/4? minus V3 over 4K, right? Minus V3 over 1K equal to 4 or 5 over 4. Okay. So this one should be right. Minus, okay. Super mesh will not be in our final, yes, of course. Because not in our syllabus, okay? Kenapa saya tak dapat? V2 minus 1 over 4K minus V3 over 1K. Yes, but it is minus equal to 1.25 milli. If 5 over 4, so no milli there. We have milli in our equation. Never mind. Later you later I will check this. Okay. But this is the answer. This is the answer. You may try later. Okay. I don't know what I. Okay, because V3 over 800 is we will get milli. We will get milli. It's okay, never mind. We go to the next question. But this is the answer. Later I will check this. Thank you, guys. Okay. So anyone cannot understand? Anyone cannot understand this question? Yes. Meaning that you understand. Okay. We go to next question. Write the current mesh equation and then determine the value of I1, I2 and I3. Okay, so please do this. I think this is basic question. Okay, let's try. Let's try do it together. In loop I1 9 I1 and then minus 4 I2 minus 5 I3 equal to 30. This is our first equation. In loop 2, in loop I2, okay, in loop I2 minus 4 I1 and then plus 6 I2 minus I3 equal minus 15. Right? This is the second equation. In loop I3 minus 5 I1 minus I2 plus 9 I3 equal to 0. Please solve. Please solve. get the same answer? Yes, Haziq. Let's check. 9I1 minus 4I2 minus 5I3 equal 30 in second loop, okay? Minus 4I1, 7. Mata tak dapat. Be very careful, okay? Minus I3, okay, that's all. Haziq, that's all. Minus 5. Okay. 7. Okay. Class, everybody get the answer? Good. Mesh analysis is very easy. Okay. Now we notice that model is quite challenging because lecturer cannot find the exact answer. The lecturer is herself. Okay. Get the same answer? Class, get the same answer? Good. How about others? Ashraf Imran, get the answer? Ashraf Imran, get the answer? Where Ashraf Imran? Ashraf Imran. Ashraf Imran. Are you with me? Ashraf Imran? Ada ke tak ada? Oh, your attendance will be si calculate. Baru nak calculate. Dari tadi. Ashraf Imran. Okay, we are waiting for Ashraf Imran. Ashraf Imran can understand or not? Attendance, madam. Sabarlah. Okay, thank you, Rivan. Attendance is here. Download. Okay, done. Ashraf Imran, get the answer? Chan Jian, get the answer?
Yes, doctor.
Good. Yung Kah, get the answer?
Yes, doctor.
Nardin Kabir,
Yes, doctor. Got the answer.
Omar?
Yes.
Omar, yes. Muhammad Hilman?
This is Hamid.
Paling becu Hilman,
Ya saya.
dapat?
Saya ni madam ada nak apa tu? Nak mendapatkan equation tu boleh madam. Nak mengira je susah sikit madam. Sebab
just
saya
in your calculator.
yang itulah saya tengah pakai kalkulator tak reti sangat. Dia ni madam yang ada kalau saya pakai yang apa model 570 ni madam kan. Saya tekan ni yang nanti dia keluar macam kotak macam matrik tu madam.
Kotak macam matrik.
Ya, ya.
570 is this. Right. Okay.
Bukan yang yang lagi satu je madam.
Okay. This one. The blue one. The white. Right.
Yang tu.
Lepas tu. And then.
Tu kita ambil kita tekan yang apa tu? Kita tekan mode madam
Yes.
Tekan mode.
Okay.
Lepas tu tu Daniel dah cakap
Daniel.
Sekejap, macam mana sekejap
Siapa? Ashraf apa tadi? Dapat dah belum?
Sekejap, madam saya cuba dulu madam
Ashraf Imran. Dah belum? Okay, other student please look at this question. Okay, we proceed. While waiting for Ashraf Imran dengan Daniel Okay, so never mind. Ashraf, Daniel and siapa tadi? Hiliman, please look at this example. So in loop I1, okay, so this is for loops. If you use scientific calculator, the old version, this one, this one, okay, this one. So it only can solve for 3 equation, okay. But this version of calculator, okay, the white one can solve for equation. I don't know up to how many equation, but for 4 equation it can solve. Okay, so actually in your exam, okay, we will ask you to solve for 4 equation, okay, because we consider the constraint of the old version of calculator. So but we can just write the equation. We cannot solve by using the old version of calculator. So in loop 1, how many resistors in loop 1? How many resistors?
3 madam.
3.
3. How many resistors? I mean value. Resistance in loop 1?
9.
9. 4, 3, 2, 9. Okay, so 9 I1, this is I1, okay, minus 3 I2 minus 4 I3. How about I4? No I4. Okay, so 0 I4 equal to 6. In loop 2, how many I1? Only 3, right? So minus 3 plus how many I2? 5 plus 3, 8. How about I3 and I4? No. Okay, no share resistance with I3 and I4. So 0, 0, and then this is what is source equal to 4. In loop 3, how many resistance share with loop 1? 4. So minus 4. How about I2? No. Okay. No. So 0. How about I3? It's a 4 plus 1 plus 1, 6 I3. And then how many resistance share with loop 4? 1 only. So minus 1. And then is there any voltage source? 2 volts. Okay. In loop 4, I1, no I1, I2, no I2, I3, only 1, so minus 1, and then 2, I4, and then we have positive 3, become minus 3 here. And then please solve, we cannot solve by using old version of calculator. Understand or not? Can understand or not? Okay, so you know how to write this, right? So this in loop 1. So minus I1 minus 3I2 minus 4I3 equal to 6. This is the first equation. Okay, then proceed to other equation. Please proceed to other equation. Okay. So any question? This is our last. This is our last question. Okay, for today. Given a figure, okay, the question did not specify what method to use. Up to you. You can use any method that you want. Okay, so the question asks you to find V0 and I0. V0 is the voltage drop across 20k ohm. Okay, I0 is the current flows through 4k and through this path. Okay, so how to find V0? V is equal to I, I is equal to 50 I0. 50 I0 multiply with 20k, we get 10 mega I0. Okay, 10 mega I0. Okay, this is the first equation. And then from the input loop, we apply KVL here. Okay, KVL. This is KVL equation. Current flows counterclockwise. Okay, we just follow I0. Otherwise, we assume that current flow in clockwise direction. Okay, so in this loop, current flows counterclockwise, so we just follow this direction. Positive 15 milli, okay, 15 millivolts, and then minus V0 over 10 here, and then this is plus. Why plus? Because current flow like this. I know current flow like this. So this is the notation of V at 4k. That's why plus 4000. Okay, the V here is 4k multiplied with I0 equal to 0. Solve these two equations and you will get I0 and V0. In this equation, two equations, we have two unknowns, V0 and I0, so that we can solve this equation and we'll get the answer. Please try and check whether you get the answer. Any question?